Now we're going to graph some rational functions with holes. Now, just want to let you know that these notes online have 5 examples, but the last 2 are just review. So we are only going to cover the first 3 in these notes. So what is a hole? Well, a hole occurs when you have something that cancels in your numerator and denominator, like back in the day when we were simplifying rational functions. Now what it does is it creates a hole because in the original function that value could not exist, but in the simplified one it does. So let's just step through one and you'll see. The first thing you always want to do when you're graphing these is you're going to want to make sure you factor the top and bottom when necessary. So the denominator has a difference of 2 squares, so that simplifies to x plus 4 and x minus 4, and it's no surprise, the x plus 4's cancel. So this actually simplifies to 1 over x minus 4. So that is in fact the graph, but the original equation has an x plus 4 in the top and bottom. You cannot have a negative 4 in the denominator in the original problem. But you can have a denominator with a negative 4 in the simplified version. So, to graph this, it's the same amount of work as it was before. You take your simplified equation to do the work. So your vertical asymptote is still what makes the denominator 0, so x equals 4. Your horizontal asymptote is still going to be more x's in the denominator, so that means you have y equals 0. But now your domain and range are going to change a little bit. Now here's the thing, we got to talk about the hole. The hole is a coordinate, it's not an asymptote. So to find the hole, what you do is you take what you cancel out and set it equal to 0, and you solve. So x equals negative 4, that's just the x coordinate of your hole. And then what you need to do is you substitute the negative 4 into the simplified equation. So it's 1 over negative 4 minus 4, which is 1 over negative 8. So your y value for the hole is negative 1/8. So now going back to the domain and range, domain x cannot equal your vertical asymptote or the x-coordinate of any hole. And the range, y, cannot equal any horizontal asymptote or any y-coordinate of any hole. So that's how domain and range change a little bit. But the rest is the exact same. To graph it, you're just going to need to graph your vertical asymptote at x equals 4. You need your horizontal asymptote at y equals 0. And then to graph it, you're just going to need to type it in the calculator. Again, you're going to need to get some nice points when possible. So we're going to have a nice one here and some right around there as well. And then we're going to have our branches. However, there's one little change. Is at your negative 4, negative 1/8, you must put an open circle. That represents the hole. It's a value that cannot exist because in the original equation, you would never be able to put the negative 4 in the denominator. All right? So that's that one. That's how you work with holes. So I'm going to ask you to pause the video, and I would like you to factor the top, factor the bottom, see what cancels out, and see if you can list your vertical, horizontal asymptotes in your hole, and then we'll check and see if you got your domain and range correct. All right? Give it a try. So did you get it correct? You needed to factor the top and bottom, and your x plus 4s will cancel, leaving you with 2x over x plus 2. Same number of x's on top and bottom, so 2x over x reduces to 2. X equals negative 2 for your vertical asymptote. And your hole was created by the x plus 4's canceling, so leaving you with a negative 4 comma, substitute it back in, and you get another 4. Your domain and range is stated. The graph is done using the graphing calculator. Do not forget to have your hole, and you are good to go. So there's one more example, and this is where you might have multiple wholes from multiple cancellations. So you factor the top, and you're going to factor out a 2, and then you're going to factor completely, and you'll have an x plus 3 and an x plus 2. The denominator needs to be factored using grouping and difference of two squares, leaving you with an x plus 2, an x minus 2, and an x plus 3. So we're going to have some x plus 3's cancel and some x plus 2's cancel, leaving us with 2 over x minus 2. So this has more in the denominator, so that brings us back to y equals 0. We have x minus 2 in the denominator, so x is equal to 2. So we have our vertical asymptote at x equals 2, our horizontal at y equals 0, and then we have to work with 2 wholes. So we canceled our x plus 3's, that's a negative 3 comma something. We canceled our x plus 2, so that's a negative 2 comma something. So you take those and substitute them back in to get a negative 2/5 when you substitute your negative 3, and a negative 1/2 when you substitute your negative 2. And then the rest is done by you just typing it in the graphing calculator, and you're going to get something that looks a little bit like this. And you have 2 wholes, one at negative 3 and one at negative 2. Alrighty, and of course your domain still follows the rules. X cannot equal any vertical asymptote, and x cannot equal any x coordinate of either whole. So your domain would be x cannot equal 2, negative 3, or negative 2, and your range y cannot equal 0, negative 2/5, and negative 1/2. This is Longo, and I'm out. See you, bye.